Alright, so in this problem we have f of x is equal to negative x squared minus 1. So in this case, the coefficient in front of x here, well, it's a negative value. In fact, this is really can be seen as negative 1 times x squared. So the negative 1's hiding, but since that coefficient is a negative number, we should see a downward facing parabola here. So our parabola should be facing downward. That curve should be downward facing. So let's go ahead and actually create a table, and I want to fix that table just some, and actually graph it afterwards. So x and f of x, and I'm just going to keep it simple still. So negative 2, negative 1, x is 0, x is 1, x is 2. Alright, so let's look at negative 2. So f of negative 2 is equal to, well, let's look at this. I have negative 1. Remember, this is negative 1 times x. So negative 1, I'm going to hide that 1 again. So a negative times, and now I'm substituting negative 2 in for x. Negative 2 in my parentheses squared minus 1. So minus 1. So my first focus is on exponents. So negative 2 times itself is 4. So negative 2 squared is 4. So I have negative 1. Remember, that's a negative 1 outside the parentheses times, well, negative 2 squared was 4. So I'm going to put a 4 here. 4 minus 1. So now I basically have negative 1 times 4, which gives me negative 4 minus 1. So f of negative 2 is equal to negative 4 take away 1 leaves you with negative 5. So we have negative 5 here, and let's box that up. Alright, so f of negative 1, we have, well, negative 1 squared minus 1. So negative 1 times itself, or negative 1 squared, will give me positive 1. So now I have, I'm going to bring this negative symbol down. So I have negative 1 minus 1. So f of negative 1 is equal to negative 1 take away 1 is negative 2. So when x is negative 1, our f of negative 1 is negative 2. And I forgot to box that up, so let's go ahead and just border that off. Alright, so f of 0, it's equal to, well, negative 0 squared minus 1. Well, 0 squared, or 0 times itself, is 0. So now basically, let me just change colors real quick. I have negative 1 times 0 minus 1. So basically, negative 1 times 0 is nothing. It's nothing, so I'm left with negative 1. So f of 0 is equal to negative 1 Alright, f of 1 is equal to, well, negative 1 times 1 squared minus 1. So 1 squared will leave me with 1. So I have negative 1. I'm bringing that negative symbol down. Negative 1 minus 1. So f of 1 is equal to negative 1 minus 1 is negative 2. So we have negative 2. In fact, let's fix that negative sign, negative 2, and border that off. And f of 2 is equal to, well, negative 1 times 2 squared minus 1. 2 squared will give me 4, so I have negative 4 minus 1. and f of 2 is equal to -4, take away 1, I'm left with -5. So now we have -5. Alright, so now I'm going to delete all this information and graph the values in the table. Alright, so let's go ahead and create that coordinate plane. And I'm going to make sure that after I get these arrows in, that I have enough tick marks in the on the y-axis in the negative direction here. So just put in 1, 2, 3, 4, 5, 6, and I don't have even spacing, but I'm trying to make it as nice as possible or accurate as possible. 2, 3, 4, 1, 2, 3, 4, and I'll just put one tick mark. And each tick mark represents 1 unit of space here. Okay, so again, I'm thinking of f of x as that y value. So when x is -2, y is -5. Let's go ahead and plot that. So -2 down 1, 2, 3, 4, 5, and 6. And actually, I want to backtrack 1. So just try to keep as accurate as possible. -2 and -5. And then when x is -1, y is -2. So -1, or -1 down 1, 2. So -2. When x, I want to fix that point real quick. When x is 0, y is -1. So 0 down 1. When x is +1, y is -2. So +1 for x, down 1, 2. And again, what you're starting to see is that mirroring effect with the y values with their corresponding x values. So let's see here, when x is +2, y is -5. So +2 down to -5. Now all I have to do from here is draw a line through those points. So passing through those points, again passing through those points, and I'm going to fix that one. So passing through these points, and what we're seeing here is messing up on that one. So let's try it one more time. So we're seeing a downward facing curve. I'm going to fix that arrow. A downward facing curve. And okay, so our vertex, again, remember the vertex is either the minimum or the maximum point of your parabola. In this case, it's the maximum point because it's the highest point because I have a downward facing parabola. My highest point is going to be the vertex in this case. So 0, -1 is the highest point. So I could just make a note that this is the vertex. In fact, I want to fix that t. So the vertex. And fix that x there. Okay, and that is it for graphing this function. Cool.